Good morning. I am Dr. Shailendra Singh Ojha. Today I am going to discuss multivibrators. So, I will discuss two aspects. One is what is multivibrator, and another one aspect is how we can design multivibrators. So, multivibrators are the circuits which can provide either high output or low output or both. So, depending on that, depending on this, multivibrators can be categorized into three parts. One is monostable, bistable and astable multivibrator. Monostable multivibrators are multivibrator which have only one stable state. For example, a multivibrator has low stable state. So, when we will trigger it, it will change momentarily to the high state and again it will come back to its original stable state. So, this type of multivibrator is known as monostable multivibrator, only one stable state. Another one is bistable multivibrator. It has both stable state. It can be stable in low state as well as in high state. So, when it will be in low state, if you will trigger, it will go to high. It will remain in high state. Again, you will trigger, again it will come back to low stable state. Again, you will trigger, it will go to high. So, it has both low and high stable state. Astable multivibrator, as its name suggests, astable. It is not stable. This multivibrator has no stable state. This multivibrator will continuously change its state from low to high, high to low, high, low, low, high, high, low, high, like this. So, that means if I will plot its output, it will be like this. That means it can generate a square waveform or rectangular waveform. So, how we can design multivibrator circuit? Multivibrator circuits can be designed, generally they can be designed with two devices. One is it can be designed with the help of operational amplifier or they can be designed with the help of 555 timer. So, here I am going to discuss the designing of multivibrators with the help of 555 timer. So, before starting the discussion of multivibrator, I would like to discuss 555 timer IC. So, if you will see here, this is 555 timer IC. As you can see, there are 3 5 kilo ohm resistors used. That's why its name is 555 timer IC. And this is 8-pin IC. Now, let us discuss the pins. This is ground pin. It should be connected to ground. Trigger. This pin is used to trigger when we will design monostable multivibrator. That time we need the trigger pin where we can trigger with negative pulse. Next is output. We can take output from fourth number of pin. From third number pin, and fourth number pin is the reset. Fifth number pin is the control voltage and it is connected over here. Very soon I will discuss its use. Sixth number pin is the threshold. Seventh number pin is the discharge pin which is connected to the transistor, and eighth number pin is the power supply pin where we need to give plus VCC to operate this 555 timer properly. This is which I have already discussed. So, no problem. I would like to explain you the brief working of this 555 timer. How will this circuit will behave and what are the various components which are used in this. See, 3 5 kilo ohm resistors, 1 NPN transistor, two operational amplifiers which are used in comparator mode. Okay, SR flip flop, and then this is reset pin, this is output, this is Q bar, like that. So see, at this point, these are 5K, 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 and it is connected to VCC. So voltage at this point will be VCC by 3, VCC into 2 by 3, and it is VCC. I have simply find it out by voltage divider rule. So now see, voltage at this point will be VCC by 3. This is trigger. If the voltage at this pin will be less than VCC by 3, this is plus, this is minus, then its output will be 1, S will be 1, its output will be set, okay, that Q bar will be 0, and like that it will work. It is Q bar 0, that means this transistor will become off. Similarly, the potential at this point will be VCC into 2 by 3, which is control voltage. Now, threshold. So, if you will apply voltage at this point, which is more than 2 VCC, 2 upon 3 VCC, then what will happen? Its output will be 1, and this flip flop will become reset. Reset means Q bar will be 1, this transistor will become active, and it will discharge through this. So, this is how various components of 555 timer are connected and how they will behave, that we have seen. So, now we can go for this is pin detail and modes of operation we have already seen. So, now we are going to discuss monostable multivibrator. Actually, this is the pin diagram. That means, if you have 555 timer circuit, then how you can design monostable multivibrator is explained over here. So, you can connect one resistor between pin number 7 and 6, between 5 and 1, between pin number 4 and there should be a resistor. These two should be connected together with VCC. So, this is, and then this circuit will start behaving as a monostable multivibrator. But logically, we do not know that how this circuit will behave as a monostable multivibrator. For that, we need to discuss this circuit. This circuit will explain us. By this circuit only we can come to know that how this circuit will behave as a monostable multivibrator. So, let us discuss this. Initially, whatever value you want, you can consider. For example, let us consider initially it is providing output as 1. We are considering, there is no problem. And in connection, this is the internal architecture of I can show this. This is the, other than VCC, this is the internal architecture of 555 timer, and we have externally connected this resistor RA and this capacitor C. Initially, I am considering that its output is 0. Initially, I am considering. Okay. So, now I am going to apply this input, trigger input, as a negative pulse. Then what will happen? Potential at this is 1 upon 3 VCC. This input is less, so its output will become 1 set. That means this output will be 1. Initially it was 0, now it is 1. 0. This transistor will behave as an open circuit. So initially the output was 0, now it has been changed to 1. Later on, let us see what is going to happen. This transistor open circuit, that means now this capacitor will start charging through VCC. This capacitor will start charging towards VCC through this resistor RA. Okay. Now this now the voltage across capacitor is going to increase towards VCC. So as the voltage across this capacitor becomes slightly less than 2 upon 3 VCC, because this voltage is already 2 upon 3 VCC, it is fixed, and as the potential of this terminal will also become 2 upon 3 VCC, then this comparator 1 will become active and its output will become 1, that means reset. That means now this 1 will change to 0 and this will change to 1. Now this transistor will become short circuit, and that means this capacitor will have this path to get discharged. So now this capacitor will get discharged, and this value again will change to low. So now we can see that its stable state is low. Momentarily it changed to high value, but its stable state is low. So this is why this circuit is monostable multivibrator, because this has only one stable state, and this duration will be decided with the help of this R and C that we will see very soon. But now you must have a clear cut idea about the monostable multivibrator. I haven't done anything. I have this circuit, I have provided the VCC, and I have done only one thing, that is I triggered this circuit with negative triggering pulse, and this is what happened. Now see, if again and again you will trigger, again and again output will get changed, but if you will trigger it only once, then you will get output like this. And voltage across capacitor is like this, it is charging, discharging, because in discharge path there was no resistor, transistor offering resistor very low resistor. So it is behaving like this, and it is going between 0 and 2 upon 3 VCC. Now actually I want to find out the value for value of time for which output will remain into the changed state. So there are two paths: sorting path when transistor is short circuited, capacitor is discharged, and another one was the charging path. So output will always change when negative pulse is triggered. This is the formula of voltage across capacitor that we all must know. So VC infinite plus VC 0 minus VC infinite into e to the power minus t upon RC, where VC infinite is the final voltage across capacitor, VC 0 is the initial voltage, and these things you already know. So in case of monostable multivibrator, we should know that VC infinite is VCC and VC 0 is 0. So at t is equal to Tp, okay, the time for which output will remain high, for this VC is 2 upon 3 VCC. So now we can put these values. VC infinite, VCC, VC 0 is 0. So you will put 2 upon 3 VCC, VCC 0 minus VCC e to the power minus Tp upon RAC, because it is charging through RA. VCC and VCC cancelled out, you will get this, you will get this. So when you will apply natural log on both sides, you will get TH minus TH RAC is equal to ln 1 by 3. So TH is equal to RA ln 3. TH is what? the time for which output will remain high. So, for example, if you have any value of resistor, pulse width, you can find out value of C. If somebody will ask you that design the multivibrator circuit for pulse width of 10 millisecond, 20 millisecond, then you can design that circuit. That means you need to find out the value of R, A and C, and you can consider the value of C at 0.01 microfarad, and you can find out value of resistor. So, in this way you can design monostable multivibrator. So, this is what which is given over here. Next is the astable multivibrator. Astable multivibrator is a circuit which has no stable state. You can see it will give you output like this, and this is the diagram of 555 timer IC, how we can connect the external components to design a stable multivibrator. And now again we cannot understand the working of a stable multivibrator without this diagram. So, now let us see how does this multivibrator will behave, or let us discuss the working of a stable multivibrator. Whatever value you want, you can initially consider. Let us consider its value is 0. Okay, we are considering. You can consider 0, 1, whatever. We need to consider at least one value, either 0 or 1. I am considering it as 0. It will be 1. Okay. This transistor will become short circuit. If there is any voltage across this capacitor, it will get discharged. Okay. Or I can say that it will discharged. This is 1/3 cc, 1/3 VCC. As the voltage across this capacitor will become slightly less than 1/3 VCC, then its output will become 1. Set, it will become, initially it was, I have considered as 0. Now it will become 1. It will be 0. Transistor will become off now. Now this capacitor will start charging through RA and RB towards VCC. So, as the voltage across capacitor will become slightly more than 2/3 VCC, this comparator will become active. It will become 1, reset, it will 0, it will 1, see, now again it will become 0. 0, 1, this capacitor, this transistor will become on now. As it will become 1, it will be on. This capacitor will discharge through resistor RB towards 0, and as the voltage across capacitor will become slightly less than 1/3 VCC, it will become active. That means again it will 1, its output will become on 0. So, I haven't done anything, I am simply analyzing this circuit. It is providing output as 1, 0, 1, 0, 1, 0 and so on, because this capacitor will charge up to 2/3 VCC, discharge up to 1/3 VCC, 2/3 VCC, 1/3 VCC. So, this is how this circuit will generate the waveform like this. You can see this is the voltage across capacitor, discharging, charging, discharging, charging, discharging, charging, and this is the output of this circuit. This is the working which I have already discussed with you. Now, function of charging capacitor. So, earlier I told you this relationship that VCT is equal to VC infinite VC0 minus VC infinite into e to the power minus t upon RC. So, while charging, it is charging through resistor RA and RB. So, the capacitor maximum charges till 2/3 VCC and discharges till VC is equal to 1/3 VCC. So, for charging case, we will consider this 2/3 VCC and at t is equal to TH. That means, I am talking about this condition, charging condition. You can put this value in this equation. 2 upon 3 VCC, VCC, Vc infinite is VCC plus 1 upon 3 VCC minus VCC e to the power minus TH RAC. This. So, if you will solve it, you can easily find out minus TH upon RA plus RBC is equal to ln 1 by 2. That means 0.693. So, TH is equal to 0.693 RA plus RBC. Now, equation of discharging, for discharging is what I will represent T by TL, and Vc is 1 upon 3 VCC, and Vc0 is 0. Sorry, Vc infinite is 0. So, if you will solve it, it is very simple mathematical equation. So, you will get minus TL upon RBC is equal to ln 1 by 2. So, TL is equal to RBC or ln 2. So, TL is equal to 0.693 RBC. Total time period T is equal to TL plus TH. You can add this TL and TH. So, you will get 0.693 RBC plus 0.693 RA plus RB into C. So, T is equal to 0.693 RA plus 2RB into C. Okay. And so, what is duty cycle? Duty cycle is the TH upon TL plus TH. That means, TH is the time duration for which output will remain high, and TL is the time duration for which output is low. So, you have both values. So, if you will put, it will cancel out, you will get RA upon RA plus RB upon RA plus 2RB. This is the duty cycle. To find out it in percentage, you can multiply it with 100. And frequency of oscillation is F naught is equal to 1 upon T, where T is the time period, and you have already find out the time period. So, F naught is equal to 1 upon T, you will put it. So, you will get F naught is equal to 1.45 RA plus 2 RB into C. This is the frequency which this multi-vibrator will generate, or any frequency you want that this circuit should generate. For that, you can design this circuit. You can choose proper values of C, RA and RB, and you can obtain the desired value of frequency. This is how monostable multivibrator and astable multivibrator will work, and you can design these circuits for any desired frequency and for any desired pulse duration. Pulse duration, if pulse duration is given, that means you need to design monostable multivibrator. If frequency is given, that means you need to design astable multivibrator. This is what which we have to discuss today.